In this video, we're going to be going over the Pythagorean identities again and how to apply them. Okay, so remember again that cosine of t is equal to x, sine of t is equal to y, tangent of t is equal to y over x, and then the reciprocals, secant t is equal to 1 over x, cosecant of t is equal to 1 over y, and cotangent of t is equal to x over y. Okay, so if we look at tan of t, this is y over x. And since we know that y is sine and x is cosine, we can rewrite tangent of t as sine of t over cosine of t. We can do the same with all the reciprocals. So we know secant, again, is 1 over x, which is just 1 over cosine of t. And then with cosecant, we know that this is 1 over y, and we know that y is sine, so cosecant is 1 over sine of t. And lastly, we know that cotangent is x over y. So this can be rewritten as cosine of t over sine of t. So let's apply some of these functions. So again, we have the unit circle. If we draw a right triangle for each terminal point, we see that, so this is the x coordinate, and this is the y coordinate, and we have a radius of 1. So we know the formula for the Pythagorean equation, which is x squared plus y squared equals 1. So using what we know with trigonometric functions, we know that x is cosine of t and y is sine of t. So this can be rewritten as cosine squared of t plus sine squared of t equals 1. Okay, so that's the first equation that we have. And we can derive 2 other equations from this. So I'll show you the first way. So to do this, we divide everything by cosine squared t. So do cosine squared t divided by cosine squared t plus sine squared t over cosine squared t equals 1 over cosine squared t. So if we do this, the first value turns into 1 plus, so we know again from what we learned earlier, this is just tangent of t, tangent squared of t. So and then this value here is just secant squared t. So this is our second equation. Our third equation can be, again, derived from the first equation by dividing everything by sine squared t. So let's do that. Cosine squared t divided by sine squared t plus sine squared t divided by sine squared t equals 1 over sine squared t. Okay, so we know again that this is cotangent squared of t plus the sine squareds cancel out, so this becomes 1 equals, this is cosecant squared t. So this is our third equation. Okay, so now let's apply these new equations that we learned into some examples. Okay, so if sine of t is root 3 over 2 in quadrant 2, so here, what is cosine t? So if we set up our equation, cosine squared t plus sine squared t equals 1. So we are given sine squared sine t, so we can plug that in. Root 3 over 2 squared equals 1. So if you do this out, cosine squared t plus 3 over 4 equals 1. Move this over and subtract from both sides. We get that cosine squared t equals 1/4. If we square root both sides, cosine of t is equal to 1/2. So we know that since it's in quadrant 2, the x values or the cosine values are all negative. So cosine at this point is equal to negative 1/2. That is the final answer. So let's check that on the unit circle. So we see that this is what we were given, and this is the x or cosine value that goes with it. So we were right. Okay, so here is another example. So this one we're given cosine, and we have to find cosecant, which we can do if we find sine, because cosecant of t is just 1 over sine of t. So cosine squared t plus sine squared t equals 1. We have that cosine is 4/5, so 4/5 squared plus sine squared t equals 1. This is 16 over 25 plus sine squared t equals 1. Subtract 16 over 25 from both sides, and you get that sine squared t equals 9 over 25. If you square root both sides, you get that sine of t is equal to 3/5. Remember, we're finding cosecant, which is the reciprocal. So cosecant of t equals 5/3. Now we have to see if it's positive or negative. So it's in quadrant 4. So here, and it's sine, so it correlates with y, and all the y values in this quadrant are negative. Therefore, the final answer is cosecant of t equals negative 5/3.